Hello friends, welcome back to the bench. Our patient today is a 1990 Mazda b2600i ECM, obviously. This happens to be my dream car, especially 1990, 1991. And the reason is that this car appears to be indestructible, because you have no idea how many inquiries do I get about these ECMs. And the problem with this one is actually a common problem on these. The cups are leaking, causing a corrosive effect on the board. So let's do a visual inspection first. Then we're gonna throw it in the ultrasonic cleaner. The liquid is heating up right now. I want a visual inspection before cleaning, because oftentimes the damage can give you a lot of, or can give you some pointers where the damage is. After cleaning, that damage might not be visible. So this is blue. Okay, I'm no chemist, but when copper turns blue, it's going to be a difficult repair. That's the rule. Now, a good part about this ECM is that it is only two layers, the top layer and the bottom layer. So even if we have corroded vias like this, it's not a big issue on this ECM, because this can be restored. If it happens on newer ECMs, we have layers inside that need to make contact, and without x-raying, there's no way to ensure that it is actually touching, and you don't know what kind of traces are inside. Again, without x-ray, you can't really do much with that. Now we can see that it looks like this is completely corroded through over here. The trace is gone. It looks like someone cleaned it. Right, we can see the scratches over here. So someone already tried to at least diagnose it. Yeah, I think this should connect connect here, but we'll see probably after cleaning. This via needs to be restored. This via needs to be restored. We have more oxidation here on this diode over here. Oh, not good. This is injection driver. I think these two. I'm not sure. Yeah, I think it's these two. And well, most likely, it might not be the case, but again we see blue tint. That is oxidized copper. So there's a lot of damage to the ECM. Even here, that is pretty far. So the cup is here, right? And it corroded all the way over here. Blue oxidation. Now the question is, do we have missing components? I will have to probably reach out to the expert. So we do have an expert for on these particular ECMs on my Discord server. He even went as far as actually reverse engineering the schematic for it. Since it's a double-sided board, it is possible. With newer boards, not so much. Even if you work with the meter without an X-ray, there's not much you can do. This is probably a diode, and it looks like there's no damage to this. oscillator looks good. Yeah, the damage didn't make it that far, which is good. Let's see around the CPU or MCU. This is Mitsubishi MCU. Oh, blue. Blue, not good. Blue is bad. You don't want to see blue color. And we're here, but it ends here. And I don't really see much damage over here. More VS to restore. These traces, yeah, looks like these traces need to be restored. 1, 2, 3, probably 4. We'll check with the multimeter, but that should be no big deal. This also looks like it needs to be restored. So first, let's remove the cap and check this out. So this cap is a 25 volts 47 mics, right? This is the cap, and the replacement is this big. And this is 105, and this is 85. So you see how much, since the 1990, see how much progress has been done on reducing the size of electrolytic capacitors. I had I think the whole video on capacitors, but just to recap very quickly, the capacitance is proportional to the size of the plates. In this case, it's like a tape, aluminum tape, rolled around. And it's reverse or inverse proportional to the distance between them. So the higher the distance, the lower the capacitance, but also the higher the voltage. The larger the plane or the surface of the plates or electrodes, the more capacitance we have. But nowadays, what they do, they actually treat the plates with acid to create the micro pores inside, thus increasing the surface of the electrode. That's why the newer caps can be a lot smaller than the ones from 1990. Okay, let's remove the cap first. This one looks fine, but we're gonna replace it as well. And this is 50. 47 and 50. Yeah, again, the replacement is a lot smaller. Interesting that there is no damage, no corrosion on the back of the board. Only on the top. Oh, and this transistor looks like it got damaged probably during shipping. We gotta check these. I would assume these are either the injection control, not the injection, the ignition control. But now looking at it, no, I don't think so, unless it's at the bottom. Yeah, they're all on the ground. But yeah, so they're cutting to ground, but I don't see what collector is sitting on. This might not be an ignition. This might control some valves, or I mean by valve I mean the you know, like some switches basically for the fans and that kind of stuff. Okay, do we have markings? We do not have markings, so let's remember that the ground on both caps is on the side of the transistors. Let's remember that, although I'm pretty sure I'm going to forget it. We could use desoldering gun for this, but it takes 15-20 minutes for it to heat up. So I think I'm just gonna use the regular solder sucker. And this is what we have underneath. Now, okay, yeah, I see it. So looks like this. So this is for injection. Yes, for injection, because these caps are on the 2 injection lines. This is 4-cylinder engine, but it has only 2 injection lines. So yeah, it's corroded through here, and it should go to this via over here, and this should go to the terminal. This should go to the terminal. So there's a lot of restoring here. Now let's check the other cap. Although this one looks good, there shouldn't be any damage down there, but we're replacing it anyways, because we don't want this thing to happen again. Okay, this one definitely leaked, but I'm not sure about this one. This could be the residue from like conformal coating or something, or it could be tiny leakage. Let's see the board. Yeah, there's okay, so there was a tiny leakage on this one as well. And what happened is the via corroded here. We'll see after cleaning. For the liquid, I use cobalt blue, which is an alkaline, so it removes corrosion very well. Also any kinds of oils and anything like that. It leaves the solder joints nice and shiny. And that's what we like after ultrasonic cleaning. There's a little bit of some kind of residue here. And is that quartz? The oscillator? Or is it like those old school transistors? Transistor package. They used to come in those packages back in the day. Alright, let's do some cleaning. Okay, it looks a lot better. And let's ring through it and see where we stand. So from here we should have connection to here, which we do not because the via is not there. Yeah. So yeah, here's okay, so that's the first breakage. This might work. I'll have to test it on the other side. Confirm the connection from this side to this side. So it, for now it looks like this is the only place where it corroded through. Let's check here. Yeah, the via completely corroded through, but via is good. Via is good, but the ring outside, the copper ring, that corroded through. So we need to connect this to this. And from here, well, we have connection, so it's only around the cap. And it does, it's not connecting to the other side of the board. We have some stuff here, let's see. Same thing here, unless this is not supposed to touch. Let's see deeper. Yeah, I'm pretty sure it's supposed to touch the. Yeah, this should be one plane over here. I think. Okay. Now, okay, I was touching the wrong thing because I thought the connection would be between here and here, but now I see that it's not. But this resistor, okay, we have connection here. This is good. Okay, because I was touching this and I didn't notice that this is actually detached from this plane here. Okay, so this should be good. Maybe not perfect, but here we have, and so this is the reverse polarity diode from, this is very important because if that diode is not in the circuit, the voltage on the injectors will grow. Because we're driving inductive load here. So without this diode, it's gonna be no bueno. Let's see here. Do we have another breakage here, I think. Yeah. Interestingly, connection is here, so that's good. It is 1.4 ohms, so we're gonna try to restore this as well. And we've got connection here, but not here. Yeah, it got eaten away over here, I think. Yeah, no connection here. And that is the second diode. It actually looks like this diode was replaced. .6 and 0.6. Yeah. Diodes look okay, at least they seem functional. So let's start by okay, let's just start restoring. Let's speed up the footage because this is going to be boring. Alrighty, so there we have it. I did, the total of 3 traces were actually damaged. The rest, I just did kind of a preemptively, some vias and some traces that looked damaged. One was particularly, actually 2 of them, but one, the whole via corroded through, so I had to run the wire from across the board, and the other one by the cap, same thing. But with the cap, you saw that I had to use 3 wires, because if you use just one tiny wire, that might not be enough. And now it is roughly an amp, if I remember correctly, an amp per millimeter of trace, right? Because it's not the size of the wire, so like the cross section. It's not the surface that counts. It's the circumference that counts. So if you take the wire and you just kind of fold it out into a trace on the board, cross section is still gonna be negligible, but it's the size, it's the surface of the trace that matters, and in the wire, it's the surface around the wire. So the wire and the tube conduct pretty much the same way. That center of the wire doesn't really make much difference, because the electricity will travel on the surface of the wire. Funny fact for you. Anyways, that should do it. Unfortunately, I am not able to test it, because the customer did ask about that, if I can test it. Unfortunately, I cannot, not yet at least, but I will be hunting for 1991 or 1990 Mazda track B series, because they seem indestructible, and you can buy one for as low as $1,500 to up to like $3,000. Actually, for $3,000 you can buy like 98, 97, 98. So maybe that's the one I would go with. But I do have a car, and I'm not quite in the position to just buy an extra car, so I will probably have to wait for my Subi to just kind of be broken enough that it won't make sense to repair it. I don't know, maybe I just always wanted to have a truck for some reason. I've never had a truck. That's a little dream of mine, very simple dream. Anyways, this should work. It doesn't look great, as you can see over here. I did seal as much as I could, but it went through ultrasonic cleaning, the total of like half an hour, maybe a little more. So pretty much all of the conformal coating is gone. So now this ECM is kind of susceptible to humidity. So I didn't check. Actually, I don't even know where the customer is from. But hopefully it's Arizona, because this will be good for Arizona. If you're above the Rust Belt, perhaps down south, Florida, California, high humidity, it's not the best. It's not the best, but it's not like a little bit of humidity and the car is going to stop working. Not at all. But that conformal coating is supposed to increase the resistance to humidity. I don't know. I have in my car. I'm in humid Georgia. In my car, I have an ECM that went through ultrasonic cleaning, and it is not sealed anymore. I don't see any problem. I don't have any problems. It's inside the car, inside the cabin. If it's inside the engine bay, then it's usually sealed around, and siliconed around, and it's in aluminum cover, those kind of things. But these just have the aluminum cover screwed on 4 screws, and that's pretty much it. So I'm guessing this should not be a big issue, but we'll see. We'll see. We're gonna invoice the customer, The ECM is worth roughly $300. So if the repair is higher than say 250, then it doesn't really matter. It doesn't really make sense to get it repaired. It's better to get the replacement, especially that these don't need to be programmed. That's why I actually get a very few of these on the bench, but I get tons of questions about these. And typically when I get like a picture or something and the description of the fault, I usually recommend that, if you want to send it to me, that's going to be close to what you get for the replacement. And all you got to do is just plug remove the old one, plug in the new one, and it's working. No programming, no nothing. And this is from the good old days where ECMs were not tied to the VIN. Well, I'm not saying that's anti-repair measure. Nowadays, ECMs actually report a lot of stuff that could be used as a forensic evidence in either insurance claims or if something happens, like some serious accident. So for that reason, it is required for ECMs to be tied to the car, so you can just easily swap it, right? You still can swap it, but you need the level A technician to program it for you, right? And I expect that if you do cloning or well, maybe not cloning, but if you do programming, then you should probably verify the ownership of the vehicle. If someone sends you the ECM, this is my VIN, then at least that's what I do. I just require that the customer send me the picture of the car in the inside of the door, so I see that the VIN is there or behind the windshield. Or some people just send me the picture, the scan of the title. In either case, I have to somehow at least verify to a certain extent that the ownership of the car, right? Basically, I don't want any problems. Alrighty, I think this will work. Let's send it to the customer. It's getting a lot warmer, so tomorrow we're gonna do some motherboards, because I think I have a couple. We got one motherboard to diagnose. We got this laptop that I finally have to get to. We need to dig out the board and see what we can find there. Unfortunately, no board view. I can't locate it for that laptop. That's why it's taking so long. I'm kind of delaying it until I find the board view, because it's going to be difficult without it. And the motherboard had a socket replacement, and it doesn't boot, and the CPU doesn't get warm. So there's no V core on it. So either I messed up the socket replacement, in which case we'll try to replace it again, or there's no V core for another reason. But I'm still waiting for the CPU to actually test it, and I actually got DDR5 from the customer, and so we're almost ready to test it. Just hopefully a few more days and I get the CPU. That'll do. Thank you guys very much for watching. I do appreciate you, and I shall see you in the next one.